Are you doing?
Yep.
Okay. Hello, my name's Mark Ryan. I'm not able to summarize the entire proposal in 10 minutes. So instead I want to focus on just one idea that I think is a kind of theme that runs throughout the proposal. And that is about what happens to your data. In particular, what kind of privacy or confidentiality guarantees about your data can you get when you use online services? And by online services, I mean the kind of familiar web-based ones. And this is the one about EPSRC proposals. It's just like a conference review site where you upload proposals and upload reviews. So the familiar web-based ones, as well as ones to do with more general kind of interacting with servers and providing data to servers, whether it's mobile phones or ticketing systems or whatever. And the question that I'm facing is, how could you feel comfortable about uploading your data to such servers? Bearing in mind that, you know, there's servers in the cloud somewhere and you have no idea where they are, and they may interact with other servers in yet other locations and so on. How could you even express a policy? That's not at all clear how you could express a policy. And even if you could express a policy, and this is the big point now, how could you be sure that the server is adhering to that policy? For example, the policy might be restricting the ability of employees of the service provider to copy it to disks and mail those disks to the post, and we've had examples of that in the past. Or restricting their ability to download the whole database onto a laptop or something like that. Or it might be to do with access control of individuals. For example, you know, in NHS records you might have this policy that specifies who can and who cannot read your medical records. So the question is, how could a user have confidence that the agreed policy, whatever that is being adhered to? And the big idea of this proposal that I want to put to you is policy verification by user. The idea that a user could get some kind of compliance proof which would enable them to know for sure that the server in the cloud is adhering to the agreed policy. Now that's something that we certainly don't have at the moment. You know, when you interact with those services, you have no guarantee at all. You may have some statement, privacy statement or something like that, but you have no guarantee. Under my proposal, you would get a compliance proof. Your browser would be able to verify that exactly the agreed policy, which would be formally stated, of course, in a formal language, is the one that's being adhered to. Now this idea is not something that has not been sought after before. In fact, there are many approaches in cryptography that try to give you something like that, albeit in rather restricted domains. So for example, searchable encryption is the idea that a user could encrypt the data before uploading it, and then the service provider tries to provide the service through the encryption. Now obviously that severely limits the ability of the service provider to do anything meaningful. I want to give a much more general solution. I mean, the solution I just mentioned there, searchable encryption, has never really seen the light of day. It's never been implemented on a wide scale because it's computationally very expensive and generally it's just too hard to manage, and it only works in very restricted circumstances. Of course, there are other solutions which also work in just restricted circumstances. The solution I'm proposing is much more general, and it's based on the concept of what's called trusted computing. So trusted computing is an industry standard, an ISO standard as well, that has emerged in the last few years for securing client-side, for securing laptops and desktops. And my idea is that it could be deployed on the server side. And therefore, an industry standard that's already very well established client-side could be made to work to answer this very different question about how you could have this compliance proof. The idea is to leverage security and privacy guarantees from hardware. So trusted computing is about rooting security in hardware. The kernel manifestation is this TPM chip. And you build a security kernel around that embodies the policy, but then the user is able to verify that that is the software kernel that has kind of exclusive access to the data, and therefore that's the agreed policy is the one that's being adhered to. Now, a lot of research is required to make that work. The way you leverage the security and privacy guarantees is quite sensitive to the details of the policy, and the way in which you can establish that a particular security kernel embodies the policy is also something that quite a lot of research is needed to do. And of course that research is described in the proposal. Okay, well, I'm going to just very briefly mention the three kind of the three large areas that this proposal is based around. The first one is the infrastructure itself, this idea of hardware-based security, so-called trusted computing. There's a lot of work just getting that infrastructure right. Then I've got a big application in electronic voting, which is precisely the sort of area where a user would want to have guarantees about what happens to their vote after they upload it. And in that situation, the policy about what happens to your vote is very subtle. There's, of course, privacy elements, but there's also integrity elements and verifiability elements. Users would like to be able to check that their vote is properly counted, and so on. And then the third package is about balancing global security on the one hand with individual privacy. That's something that, of course, there's a lot of debate about in society, and I think that the contribution that this fellowship could make would be to point out ways in which that can be done based on this notion of using hardware-based security at the server side. Well, I want to just focus on why me, why now, and why should this be funded through a fellowship? So why me? Well, because I have this breakthrough idea, this idea of using trusted computing server-side is kind of delivering a holy grail, I think, in computer security that's made possible by this emerging standard that has come from industry. And I also want to point out my industry involvement. You probably know from reading the proposal that I have £230,000 of match funding from industry, of which the biggest part is £130,000 from Google. And I feel I've just amassed precisely the right team, both in terms of industry and academic collaborators, to make this work. I'm uniquely positioned, I believe, to make it work. I was at Hewlett-Packard for an industrial secondment funded by the Royal Academy of Engineering last year. That's where I found out a lot about this industry standard, and my background in analysing security systems generally. I think those two things together make me very well positioned to do this. As far as why now is concerned, undoubtedly society is facing major security and privacy threats, and these are certainly not going to get any better unless we have some radically new approaches, of which I claim this is one. The other kind of theme that runs throughout my proposal is a focus on properties, because I think that the right way to solve security and privacy threats is to understand better what properties security systems are meant to provide. Now, why should this be done through a fellowship instead of, for example, ordinary responsive mode? Well, the biggest thing that I need is time. That's what I like most. And I think that's what this fellowship could provide. It takes a lot of time to get that industry involvement, to talk to companies. It's very, very well worthwhile to do that. I mean, incredible benefits accrue from having that kind of industry contact and that direct impact on industry. But it takes an immense amount of time, and that's what I need. And it's the kind of discussion that cannot be delegated to postdocs or PhD students, because it's taken me years to understand how to interact with industry, and I can't expect people who are much younger than me to be able to do that. I think I'm at a crunch point in my career. I've had this great idea, I believe. I am uniquely positioned to carry it out. I have amassed a team to do that, both through industry and academic collaboration, and therefore I feel that everything is in place for me to get that impact. Thank you for your attention.